So what we have to do is factor our denominator. We factor out the x. Okay? So that's what we want to break this up into. X and x plus 1. We are undoing. Okay, now, the main reason we're doing this, it does tell us a little bit about the graph, but it's really going to give you a leg up next year. When you start calculus and you start taking integrals, this process is really important. And it's good that we're introducing it this year.
Okay.
So that next year it'll make it a lot easier. You'll be like, yeah, I've seen that. Now what are we doing with it? Okay? So with this, when we break it up, we don't know what goes here, we don't know what goes there, and that's what we're trying to solve for. But we do know for these fractions to be equivalent with the same denominators, these numerators would have to be equal. Okay, so we got to get the same denominator over here. So to do that, the A gets multiplied by the x plus 1, and the B gets multiplied by x.
What I've been doing is I've been just getting rid of the denominator because after that point we don't do anything with it.
Okay, and this is right here is where we can.
Okay.
Because these fractions are equivalent and the denominators are already equal, all I have to do is set the numerators equal and solve. So I'm going to distribute that A.
Yes.
Okay? Now, I see x's over here, I see x's over here. I'm going to group the x's over here.
I feel like it's going to give us
And then I'm going to factor out the x. Actually, let's stick it at the end. Doesn't matter where I put it.
I like it in the end.
Okay? Now, I have the constant here, and I have no x with the a there. So at this point, for these two things to be equivalent, this one has to equal this one, and then this one would have to equal that one.
Systems.
Okay? So,
but it's A equals 2, so it's not
the 3 equals a plus b.
B is 1.
The 2, green,
X.
the 2 has to equal a. So we know a is 2,
B is 1.
and so b is 1.
We gotta read it.
Okay, now, if you left it right there,
That's it.
you're wrong.
That's right.
Because I asked you to do the partial fraction decomposition. You've done all the work. Now all you have to do is write the answer. So, the answer, if we were to take 3x plus 2 over x squared plus x and break that down into partial fractions, it would be the 2 over the x and the 1 over the x plus 1. Okay, Nick, then Colin, then Dalton. Go.
This is not that relevant, but you said partial, so is there full decomposition?
Now, we're breaking it up into its parts.
Oh, okay.
So part decomposition.
Instead of like writing it like the very top one, can you just rearrange them in your head and you have to like show?
Yeah, I can do a lot of these steps in my head, but if and you can too. But if I did right now, I'd confuse a
If I
lot
got
of
the test,
people.
I'd be allowed to just start it with.
You can. Just be careful, because sometimes if we try to do too much in our head, it gets jumbled.
Yeah.
Okay, Dalton?
Whenever we write our final answers, we have to write the initial.
No, you can just write your final answers this part. I just want to show you that this turns into that. Liza?
Are the numerators, when you split it, obviously just going to be plain A and B?
Nope, let's do one that's not just plain A and B.
Yesterday we did A and then BX
BX
plus C.
Yes,
So why
ma'am.
wouldn't this one be like A to BX?
Okay, guys,
Oh.
this second fraction is just b over the x plus 1. The reason why, when my denominators are just linear expressions, an x to the first power, an x to the first power. When they are linear expressions, it just has to be over a and b. But this next one will not be that way, okay?
C.
This is our example 2. Yes, Dalton?
Can we do one that's like A and then bx squared plus cx plus b?
No, we cannot, because that would not be on a test.
For bonus.
We're gonna, baby steps, Dalton.
Dalton, baby steps.
We need leads, we don't need.
Giant steps.
No, we need stuff.
Alright,
One small
so
step.
here's
for
our
the-
next one. Alright, so Carson, what do we do first?
Factor both of them to make it easy.
Well, if the numerator factored, that'd be helpful, but it doesn't. But the denominator does factor. Okay? So we can use
Factor out
four-term
x.
grouping. What do the first two terms have in common?
X
What does that leave me?
X.
X minus 1.
Okay, so what can I factor out of the second group to be left with x minus 1? A positive 1. So this factors to
X plus.
X squared plus 1, X minus.
X minus.
x
Holy
minus
crap, I
1
didn't even know you could do that.
and x squared minus 1. Now, because the second binomial factor is a quadratic, oh, that's plus 1.
Yeah, I was confused.
Is a quadratic that does not factor further. Okay? Because of that, then we're going to get that bx plus c when we split them in just a minute. It's an irreducible quadratic factor because it's a quadratic factor that doesn't factor further. So when we take that as x squared plus 4x plus 1, and we break this up now, the first factor was just x minus 1.
Does it matter which one you use? Like, if I were to use the x squared plus 1 under a?
Then your first one would be ax plus b
Because it's a thing of two.
because it's a quadratic. Okay? Now the second factor is a quadratic. And because it's a quadratic, this should be bx. Sorry, hold up. That's a b. This should be linear. Bx plus c.
So always has
So
to
we
be
go
one
down a
degree
degree.
less.
We go down a degree, yes.
That makes the horizontal asymptote 0.
What?
If we're, well, I'll show you what happens then. Our book has some really interesting problems in it, and you guys see that we're around page 614.
We have a book.
Yeah,
So
yeah.
if the ones we're doing in class aren't challenging enough for you, that book that you checked out and took home earlier this year,
The one was like the math for.
yeah,
Math textbooks in there.
yeah, it has good problems in there. All right, so we do the same process here. So the a has to be multiplied by the x squared plus 1, and the bx plus c
X minus.
has to be multiplied by x minus 1. So that we can now have this common denominator, so that we can set the numerators equal.
Do you still need that? Like, do you have to put the common denominator in this situation? Do you just, like, not put it?
Okay, I always show the reason why we're doing what we're doing. Whoops.
Wow.
And the reason why we're doing what we're doing is because the only way these two fractions can be equivalent, if the denominators are currently equivalent, is if the numerators are also equivalent. So, x squared plus 4x plus 1 has to equal ax squared plus a plus bx squared minus bx plus cx minus c.
That's kind of
Okay? So now what we do is we group by degree. Okay, so over here we're putting the x squares together.
This one's weird. This is a negative bx.
Okay? Then we're going to put the x's together. Then we're going to put our constants at the end.
A minus C. Whoa, didn't we do this one already?
Yeah, I feel like we did the same with that.
It looks like the exact same.
They are very similar. Yeah, it's the exact same process that we use over and over again.
Oh.
All right, so this gives us a coefficient of a plus b for our x squared. This gives us
X minus
This one, yeah.
a negative b plus c for our x.
This is cool.
Okay, so let's deal with these squared terms. The only way this can be equivalent is if 1 is the same as a plus b. If 4 is equivalent to negative b plus c. And if 1 is equivalent to a minus c. And at this point you can group them however you want, whatever you see. I see that if I put these two together, the c's would go away. I don't know what you see. Okay, you do it differently. And that gives me 5 equals a minus b. And then I see if I put that over here with this. Just depends on how you see it. You may see it in a different order.
Wouldn't it be easier that this one be a lot easier?
Oh my.
Yes, you may use matrices.
So 8 equals 3.
So A is 3.
A is 3, so what is B? B is negative 2.
Negative 2? Wait, you say negative 2, Mike?
Wait, no, wait, it'll be it'll just be positive two, right?
Yep, C is positive 2.
No,
No.
B is positive.
A is 3.
No. I see.
So funny,
Never mind.
dude.
I'm going too fast for myself.
dude.
I need to slow down.
And C is 2. Maybe it's
Okay. No, it's.
been weird things. Okay. But the thing is, I've done all this good work. And
Well, you're not
this
done.
is, yeah, I'm not done. So it's A over the x minus 1 plus bx plus c over the x squared plus 1.
So what's the,
And that's it.
So you put A over the A, and then BX plus C over
What-
the 2.
Once I get the A, B, and C, what I'm doing is I'm going back to right here and plugging in the A, the B, and the C. That's all I'm doing. Okay?
Why did you need the C?
That's simple enough.
Can I do this over water?
Alright, so the back of your worksheet has a lot more practice. I'm gonna quit recording and then answer some more
Is that
questions.
homework?